All right, welcome back everybody to the last section. We're going to be talking about the Doppler effect. Pretty cool. It's a very short topic just because we're not going to go too much into details of things. But we've probably all experienced the Doppler effect, especially when we think of sirens, sirens coming toward us, sirens going around, away from us, and just how that all works. So, talk a little bit about that. So the Doppler effect is the change in frequency or wavelength of a wave as observed by someone moving relative to the source of the wave. If the source and observer are moving toward each other, the absorbed frequencies increases higher pitch. If they're moving away from each other, the observed frequency decrease, lowering the pitch. Example, sirens. This is a very common example. As an ambulance approaches the pitch of its siren sounds higher because the sound waves are compressed. As it moves, the pitch sounds lower because the sound waves are stretched. So here's an example of it. So this car over here this siren over here is emitting a sound, and let me change the color to this. So if the siren was stationary, it just emit a sound equal distant like this. But since it's moving, we can see that since the sound is moving and we know sound moves at 340 meters per second, what's happening is the sound is getting more compressed over here. Okay. And because it's getting more compressed, that means there's a shorter wavelength. And with that shorter wavelength, it's going to be a higher frequency and the pitch is also going to be higher. On the other side, since it's moving away from this person, the wavelengths are longer. And that longer is going to give us a lower frequency, and the pitch is going to be not as high. Okay? So like kind of we learned before, if the source and observer are moving toward each other, the observed frequency increases because the waves are bunched up much more closely together. They're much more compressed. If they're moving away from each other, the observed frequency decreases, lower pitch, because it's a lot more spread out. All right, so a few demos to kind of show how this all works. And here we go. So we're going to just do a few examples just to make sure everyone understands. When a sound source moves towards a stationary observer, the observer perceives A, a lower frequency, B, a higher frequency, C, the same frequency, no sound. So pause it, just try to see what you think of. But the answer is going to be higher frequency. We just talked about this. So also, if this person moves towards it, what's happening is the sound waves are going to compress and he's going to hear a lot. The wavelength is going to be less and less. But in most cases, the source is going to be the one that's moving, and then what's happening over there is the wavelength is going to be compressed with a higher frequency. Okay. As sound wave moves away from its observer, what happens to the wavelength of the sound? The wavelength increases. So as it's going away, it's getting kind of like further and further. Over here, it's very compressed. But over here, since it's going away and emitting the sound, it's getting further and further, and it's not doesn't sound as loud. The pitch becomes less as well. Okay. If a siren is moving away from the listener will experience a blank in the pitch of sound that he or she hears. It's going to be a decrease. And we've experienced this all in real life and everything, so you can very much use your intuition for this part of the unit. But that's pretty much it, guys. Thanks for watching and learning about the Doppler effect. See you with the next one. Bye.